So hello everyone. I would like to welcome you again in today's webinar. Thank you guys for joining us. Before we start, I just want to quickly present myself. My name is Mehdi Soufaini. I'm a mine planning consultant at Datamine for almost 4 years now. I'm responsible for anything that has to do with mine planning, from strategic planning to pit optimization, life of mine plan to design short-term and medium-term planning. So in today's webinar, we're going to discuss Studio NPVS Plus, which is our newest tool when it comes to life of mine scheduling and optimization. This is the agenda of the webinar. So we're going to start with a quick overview of Datamine, what solutions we offer. Then I'm going to walk you through the history of the software. So since the first release until now, who can use Studio NPVS Plus? What is new in Studio NPVS Plus? What is the new Maroma optimization engine? And then we're going to proceed to do a live demo inside the software, and we're going to finish with some Q&A. So Datamine offers solutions for every stage of the mining life cycle. So today we support every critical mining function, from exploration to geology, planning, production, sustainability, and then obviously labs. So this matters because when your systems your teams and your data are all connected, you're not just managing operations, but you're optimizing them as well. So obviously, Studio NPVS falls under the planning side of the solutions. And as you can see, it has in the planning side, we can also offer other software for strategic planning, design for both open pit and underground. So now let's go through the history of the software. In 1999, Datamine released the first NPV scheduler, which a software that can help you to optimize your bits, generate pushbacks or phases, schedule these pushbacks, considering track hours, stockpile management, and also it supports multi-mine if you have a multi-mine project. So the difficulty or the challenges with this version was, so you need to do all the block model preparation and surface preparations before you start the optimization. So you needed another software that to prepare your block models, add all of your attributes, maybe cut it with the topography before you run the optimization inside NPV scheduler. In 2020, we released the first version of Studio NPVS that can do all of the above, but now it is hosted in a studio environment, which will allow you to do all the data manipulation necessary and the block model preparation that you need before you run the optimization inside the software itself. It also had some very advanced reporting functionalities, and also it will allow you to do the sensitivity analysis on your pits. In 2025, we released the first version of Studio NPVS Plus, which can do all of the above, but now has a new optimization engine that we're gonna talk about shortly. So the same way in Studio NPVS replaced NPV Scheduler, Studio NPVS Plus will replace Studio NPVS in the near future, and we are more than happy to walk you through that change. So this is just some of the key features of Studio NPVS and Studio NPVS Plus. So as you can see, it's both an optimizer and that is hosted inside a studio environment. So you can do all of the data preparation, exporting, importing, creation of legends, and all of that inside the software itself. It has some very superior visualization tools. You can visualize your surfaces, your block models, etc. It can automatically generate reports for every stage of the optimization, and these reports are fully customizable. You can generate your pushbacks automatically. You can run your sensitivity analysis, and it is suitable for companies and projects for any size, from small consulting companies to big operations. And it is adaptable and can be integrated with any software for downstream planning processes for short-term and mid-term. So who can use Studio NPVS Plus? So Studio NPVS Plus can be used by resource geologists to maybe construct a resource model with an economic bit, to report on resources and reserves. It can be used also by mine engineers and managers at corporate office to do study acquisitions, pre-feasibility study, feasibility studies, trade-off studies, etc. It can also be used by mining engineers and managers at mine sites to do reserves update, life of mine plans, etc. And it can also be used by consultants. So what is new in Studio NPVS Plus? So Studio NPVS Plus uses a new scheduler or a new solver that is developed by Maroma Technologies. So this schedule is the most powerful solver currently available on the market and is tailor-made for mine planning optimization. So for those who are familiar with Studio NPVS, Studio NPVS Plus combines the schedule, the MLO and MFO at the same time in one scheduler. So it will allow you to combine all of the steps into one step. Maroma Scheduler will allow you, and it can support multiple parallel constraints and can study and honor all of them simultaneously. It is capable of dealing with variable length periods, so you can do quarters, you can combine between quarters and years, or you can combine between years and multiple years. It has a very simplified workflow, which makes it easier for engineers or consultants that are not seniors or not that experienced to do and develop very advanced and complex schedules. And the software also supports Datamine's new DMX file format. So what is the Maroma scheduler? So the Maroma scheduler or the solver, it works with mixed integer programming, which means it can handle both continuous values like tons, costs, and revenues, and discrete values like yes or no decisions and whole number equipment. So think of it as a smart calculator that it doesn't just crunch numbers, but it builds the best possible mine plan while respecting all of your operational and strategic constraints. So how does Maroma solve a problem? So these Maroma solver follows these three steps. So the first step, it will try to relax the issue for you or relax the problem. So will allow for a fast solution that might not be practical. So it is fast, it allows for fractional decisions, and this solution might not be practical. So once we have that solution that is fast and relaxed, the next step is to start forcing those integer decisions. Is it realistic? Is it respecting my constraints, and so on, until it finds a solution that respects your optimality gap. So depending on the optimality gap that you can define, the software will stop when the solution is close enough. And as a result, you have a solution that is practical, that is optimal, and that it honors and respects all of your constraints simultaneously. So this is just like a quick example to explain briefly how the Maroma scheduler will work. So in this example, we have three blocks. We have three blocks of ore. We have A, B, and C. So A is a high grade, but is very expensive to mine. We have B, that is medium grade, and then we have C, that is low grade, but it's very cheap to mine. So we have two constraints here. The first constraint is you can only mine one block this year. So the software needs to only mine and choose one block. Then second constraint is that ore must be sent to either the plant for processing or to stockpile. So let's try to apply those three steps that I explained earlier and how Maroma will does it. So the first step, like I said, it will try to relax the problem. So this is the first solution. It will say, okay, you can mine 50% of A and 50% of B. Remember, this is not practical because in the constraint we said only mine one block. So it is not realistic, but it is fast. And if I mine this like 50-50, it will give me around 11 million of profit. Okay. The next step now is to start forcing the constraints. I can only mine one block. So now the software will say, okay, let's mine B completely and leave A and C. As a result, I will have a profit of $10 million. So this is a gap of 9% from the initial profit. The fourth step, if I am not happy with that gap, like I said, the optimality gap, I can define it. So let's say I I want to look for a more optimal solution. So if I lower the gap and make it, for example, 5% to whatever, the software will start looking for other solutions. It will take more time, but it might find that maybe let's mine A instead, and as a result, will give me a profit of $10.8 million, which is a gap of around 2%. So we reduced the gap from 9% to 2%. So this is basically how the Maroma schedule will work. And now let's proceed to do a live demo inside the software. So this is how the software looks. So for people who are using Studio NPVS, it's a similar interface, same everything. The only change is in the task span and the optimization part. So if you can see here, now you no longer need the to do the MO and MFO. So all of them are combined inside the schedule. So let's open the settings. So as you can see now, the settings are a little bit different than what it used to be in Studio NPVS. So, and like I said, it's a very simplified workflow that will allow for even less experienced engineers to run very complex and advanced schedules. So first, we start by defining the periods. As I said, Studio NPVS will allow you to first define when do you want to start, so you can define which quarter you want to start with and what year. And it will allow you to be flexible when creating periods, so you can combine between quarters and years. So let's, for example, let me delete all periods. Let's say I want to do 12 quarters and then 15 years, and you can create. And as you can see, it will do first 12 quarters, then it will do the years. So this is if something that you want to do, the software will allow you to do that. Other than that, the software will also to combine between years and multiple of years. So let's say I want to do the first 15 years by yearly, and then I want to do for example, let's do here 10, and let's do here, for example, 5. So 5 of multiple of 5 years and create. So the software now, what it will do is it will create the first 10 periods for each year, and then the following 5 will be a multiple of years. So for 5 years. So this is very helpful when you have very, very long life of mine that exceeds, for example, 50 years. So you can do the first 15 or the first 20 years like yearly, and then you can do the rest as multiple of years. So let me delete all periods and let me do the 15 years. Great. The next step is to define your pushback. So the software will allow you to use default pushbacks and topo if you want to use the pushbacks you've created inside the software with the pushback generation engine, or it will allow you to import pushback file that you want to use. So once you import that pushback file, the software will give you the number of pushbacks available, the name of every pushback. So you can define here the minimum to mine. So the minimum to mine is basically to define the minimum mass to be mined from a pushback when mining for a pushback starts or resumes. Then you can define the bench lags. So the bench lags will allow you to define the sequence of your pushbacks. So you can either do the sequential by defining the bench lag here, for example, or you can do as a custom sequence by defining the leader pushback, the follower pushback, and then what is the minimum bench lag and the maximum bench lag. For example, the minimum is 2 benches, the maximum is from 5 benches, and you can click on add. Okay. So for us, we'll do sequential and we'll make it like this. Then we have the mining rate. So the mining rate is basically where you can define the capacity basically of your operations. So what is the minimum and what is the maximum to mine? So you can define the mass units per kilotons per day if you want to define the rates per day, or you can define them as million tons per annum. Okay, so these mass units will follow you all throughout the scheduler, so choose your mass units carefully. So if you want to do a kilotons per day, so all of your targets, all of your capacities needs to be kilotons per day. If you want to use millitons all throughout the schedule, you can use million tons per annum. So the use loaders to define max mining rates is disabled for this current version, but it will be enabled and supported for future releases. Here you can define your minimum and maximum rock mine rate, or basically your mining rate. So it can be a fixed value or it can be a variable value. So if I want to define a fixed value for all of my periods, all I need to do is select those periods, define the default, for example, 10 million as a rate, then I will click on set selected. And now the software will apply all of those rates on the selected periods. If I want to delete some of these periods, for example, I did something wrong here and I want to delete these, I can just click on rest selected. And now those are automatically deleted. Or I can simply click on reset all to delete all of those mining rates. So let me select all of them. Let me select 10. So usually we define the maximum. Okay, maximum is read it, and then you can run the scheduler and see how the solver will react. Minimum, you can also define it if needed, but the more you constrain your schedule, the more times it will take to find a solution for you. The next step after defining the mining rates is the bench advance. So the bench advance node is used to define the maximum syncing rate as well as when pushback starts or finishes. So as you can see here, we have 5 pushbacks. You can define what is the maximum benches to be active in a certain period. Then you can also define when do you want to start a pushback and when do you want to finish it. Okay, you can also define what is the maximum rate per day, and as a result, the software will automatically calculate the syncing rate for you. Now, the next step is to define the stockpiles. So when defining stockpiles, so the software will allow you to add all of your stockpiles here. As you can see, I have low grade, medium grade, high grade. I can easily add, for example, another stockpile by clicking on plus. So once you define a stockpile, you can define the capacity. By default, it's 50, but you can easily change it. If you can define the maximum reclaim. So this is if the stockpile has a variable supply or no. If a stockpile has a variable supply, you can just click on it and click on set, and you can define what is the maximum reclaim per period if you have a reclaim that is variable with time. For example, for example, 5 years, I can only reclaim up to 2.5, and then for the following periods, I can reclaim up to 5 million, and so on. So you can have something similar to this if you have a variable reclaim. You can also apply what is the recovery adjustment and what is the rehandling cost for each period. You can also define, like I said, the rehandling costs, the stockpile recovery adjustment. You can specify which rock the stockpile can take if you have multiple rock types. Let's say this one can only take the fresh, can only take, for example, the fresh, so you can select only the fresh. That means that only fresh is allowed to be sent to the stockpile. Then you can define if the stockpile can send rock to the mill, you can select it and you can define the processing costs, the AU recovery and CU recovery based on your elements. Then the initial states is used if you have initial ore available in each stockpile. So you can define what is the current mass, what is the current volume, and what is the quality of your product sitting in that specific stockpile. If you want to delete a stockpile, you can easily click here to delete. The order will control the priority of the stockpile. So if you have two stockpiles that can handle, sorry, so two stockpiles that can take the same rock, you can define what is the priority, depending on distance, depending on costs, or depending on any of your constraints or parameters. After defining the stockpiles, you can define external sources. So external sources is used to define, similarly to what we did in the stockpiles, to define sources that has maybe ore before we start the operations, basically before we start the schedule, or something that will feed my plant besides my pit. It can be, for example, an underground mine. So you can see, okay, I have an underground mine that's also feeding my is going to feed my mill, and then you can define, does it have like a variable supply the same way we define it for stockpiles. Now if this mine has a variable production, you can also click on set to define how much tonnage it's going to give me per period. For example, for the first up to 2030, it can only generate up to 3.5 million tons. And then for the following years, it's going to generate up to 4.5 million. And you can also define the volume, and you can also define a purchase cost if it has additional costs like transportation, mining costs, and whatever. You can add it as a purchase cost or additional cost. Another way that we can use for external sources are, for example, if we are purchasing material for blending purposes, for example, you can also add it as an external source with variable supply or fixed supply, and you can add the purchasing cost for that. So let me delete this one. Then ore destinations. So ore destinations is used to define the capacity or the min and max ore that I can send for each destination per period. So for example, for the mill, I can define what is the maximum rate for this stockpile. For example, what is the maximum capacity? What is the minimum that I should send to each destination. And same way I can do it for stockpiles as well. So let's say, for example, for the mill, I want 0 for the first, that is, I cannot process anything for the first year. The second year I can process up to 2.5, and for the following years I can process up to 5 or up to 5 million, and click on set selected, the same way we used to do when applying mining rates. So the ore bins. So the ore bins can be used to define the grade resolution details for the Maroma solver. So the rock mass from each pushback bench is subdivided in parcels created by rock type and the bins for this rock type. So more mining blocks and more parcel can increase the processing time, but will allow for more flexibility when dealing with different grade stockpiles or when blending. So these values are set automatically. The software will automatically create 25 bins. You are more than free to either increase or decrease the number of these bins. Grade constraints. So grade constraints are used when defining, when controlling, for example, for your ore destinations. So let's say, for example, your mill can only process grades above, for example, 0.5 or 0.6 ppm for gold. So you can just select the periods. For example, let's say this is applicable for all periods. Then you can define which element you want to use. I want to use the gold, and you can say I can only send up to only 0.5 and above. So 0.5 is the minimum grade that the mill can allow for. Same way you can do it for low grade stockpiles, medium grade stockpiles, and high grade stockpiles. Then the quality constraint. So the quality constraint is where you can define your targets. Okay, so you can define your targets here. You can say, for example, these targets can be either, for example, it can be either like or target, for example, or target. That means this is how much ore I need to mine um, every year for every period. It can be a ratio as well, like for example, your strip ratios or a formula. So the ratio will allow you to define numerators and denominators as well. For the rate, you can only use a numerator. So when defining targets, first you need to define the variables you want to use to calculate that target. So the variables, you can add them from here. So you have different inputs, basically what is the input of like the tons wise. So this, for example, is it trans, is it fresh, is it rock sitting on the low grade stockpile, rock sitting on the medium grade stockpile, high grade, or waste. And you can also control by destination. Am I controlling the transition, the trans rock or the trans ore that is going to the mill, or I'm trying to control how much I'm stockpiling for the low grade and so on. And you can also control by elements. So once you add all of your variables necessary, you can start applying different formulas. Okay, and then when applying those formulas, you can define your minimum target and your maximum target. Okay, so I'm going to delete this one. And finally, options. So options, so first we have the stockpile type. So you have two stockpile type that you can use. You can use warehouse stockpiles. So warehouse stockpiles will compute faster and are suitable for projects with larger number of periods. So with this option, a stockpiled block is considered available or reclaimed, to be reclaimed, sorry, with its own grade without mixing with other stockpile blocks, okay? The maximum periods of to reclaim, so this is basically will control the maximum number of periods a block can be stockpiled before being reclaimed, okay? So you can also control the period. The mixed stockpiles, so the mixed stockpiles in this case, so the grade of a stockpile is weighted as a weighted average of the blocks sent to the stockpile. So using mixed stockpiles might increase the computation time, but it is very good when it comes to consider using warehouse type. If you want to consider for blending and a cut for blending, the mixed stockpiles is the way to go. So these are different settings for the optimizer solver. So you can define solver time, basically what is the maximum amount, what is the maximum time when the solver should stop. So this is basically if you have a very huge project and you can set out a maximum for when it reaches that maximum, the solver should automatically stop. You can control it should allow the schedule to mine all, or you can leave it disabled. So the mine all basically will force the solver to mine all blocks, even though the software might find some blocks that will have a negative effect on your NPV. If you uncheck it, the scheduler, sorry, might leave some blocks behind. Then this is just the cores. The number of cores is, like I said, something specific to the scheduler. And then the optimality gap is where you can define what is your tolerance. It can be you can be 10%, can be 5%, 2%, and so on. Okay, so the lower this value is, the longer your solver will take time to generate a scheduler for you. So once you run the schedule, you will have the scheduler here. So per year, as you can see. So these are different years. And as you can see, the mine total doesn't exceed the 10 million that I put out. I have like in the 2036, I have the 10 million. Then you can also have your periods, the mined ore, the mined waste, how much ore is going to stockpile, the volume, and so on. And you can have all of these attributes that you can use to analyze your schedule. The same way, the software will show you or will visualize or will give you a table of the stockpile evolution, basically how much ore is going in, how much ore is going out, and it will give you that by tons, volume, and grades for each period. Okay, so the software doesn't support. So for when it comes to the part of the schedule, it doesn't support the new reporting utility that we have in Studio NPVS, but it will be implemented in the next version, which will be released in the first quarter of 2026. So you can also have visualize your schedule and create automatic charts and graphs when generating a schedule. You can also see the progress per bench um, for different pushbacks. So as you can see here, so this is my pushback 1. It will start in 2025, go up to 26, 27, 28. Pushback 2, this is when it's going to start, this is when it's going to end. Pushback 3, when it's going to start, when it's going to end, and so on. Okay, so let's say, for example, now I want to, okay, before we do that, I want you to, you can also visualize your period bits, basically your end of period surfaces after the end of each period. So I can automatically visualize those periods. So this is after period 1, year number 1. This is after period number 2, after period number 3, number 4, and so on. Okay, so this is how the schedule will work. So let's say now, for example, where is my schedule? There it is. This one. Yeah, this one. So let's say, for example, I want to control pushback number 3 and finish it earlier than 2034, for example. So I have here an example, a second scheduler that I used to end pushback 3 by latest to be finished before 2033. So let me switch to that example. So you can switch between scenarios just by double clicking. And now if I go to the settings, you will find that if I go to bench advance, I said, okay, for pushback 3, I want to finish it by 2033. So you can easily copy settings from the first one and copy it in the second one, then change what you want to change, and then you can click on save and then run the scheduler. So once we run that scheduler, I already done that. So I can, if I go and I check the schedule by pushback, I will find that now pushback number 3 finishes before 2033. So now the last year is 2032. So you can use, like I said, the start date or the end date to control when a pushback should start or should end. I can also, for example, if I'm not happy with this and I want to start it, for example, for pushback 2, for example, I want to start in 2026, I can change the date and make the start date to be 2026 instead of 2025. Okay, so now let's do another scenario where, for example, I want, let's do a new case study. So I'm going to click on add. I'm going to call it schedule 3, and it's going to have an OR target. Or target like this. Okay, so if I go to my schedule, I can see that the OR target is all over the place. For example, here, let's say in this period, I have around 1.9, and I want, for example, I want a minimum of 3 million of OR yearly, for example. So I can define I can add a target and define a minimum that I will say, okay, I want a minimum of 3 million for each period. So let me copy, I will copy the settings from the base case, copy it, settings, paste. I will switch to the scenario by double clicking. Okay, then I can go to the settings, optimization, scheduler settings. As you can see, I will have all the rates and everything. And now I can just go here and say, okay, I want to add a new target. I will name it or target. Okay, then I will define a formula for this ore target. So ore target is basically ore that it's going to be mined, okay? So that it's ore that it's coming from the pit. So this ore that is coming from the pit can either go directly to the mill for processing, or it can be stockpiled. So the formula should be something like this. So it's basically I have two types of ore. I have the transitional, then I have the fresh. So it's equal to the ore, the transitional ore that is going to the mill, and it coming from the pit going to the mill, or coming from the pit going to the low grade stockpile, going to the medium grade stockpile, or going to the high grade stockpile. Same thing for the fresh. Okay, so I can display my formula from here. So this is basically, so this is my ore target. So it's transitional ore and fresh ore that it's coming from the pit, or basically mined, and this ore can either go to the mill or it can go to the stockpile. So once you define that, you can define a maximum, for example, as 210, and then you can define a minimum that I will put as 3. And then all you need to do is to save, and then you run. So once you run in the optimization output, the software will try to have different steps. So the scheduler, it will try to create the activities, and then it will start doing the optimization. So the software now is looking for a solution that respects the targets that I'm going to put out. So we're just going to wait a little bit. I think it's almost done. And as you can see, the solution is saved and it's 100% done. Now, if I go to the mine ore here, you can see that the minimum is 3 million. I have in 2035, I have 2.9, which is still pretty close to the 3 million that I put as a minimum, and it still respects the optimality gap that I put out as 5%, I think. So this is basically the NPVS Plus scheduler. So in future releases, like I said, we're gonna support the new reporting utility. We're gonna support multi-mine, and then we're gonna support also track hours and yeah, like track hours and multi-mine. I mentioned that already. So I think this is it when it comes to the live demo. So now we can proceed to if you have any questions. Okay, I can see there's a question from Willy. So is it applicable for underground mining? So no. So Studio NPVS is specified for open pit mines. So the only way when Studio NPVS comes into the picture for underground mining is when considering if you have, for example, a pit and you want to consider switching to underground. But other than that, it's not built for underground mining, no.
So, Mehdi, there is a question from Tabang. So he said that is Maroma able to overwrite the destination of the material that the software defined on the UP generation?
Where is that question? Okay, so is in the chat. So
Is it is
Almahdi,
yeah.
quick one. Is Maroma able to override destination of the material that the software defined on the UP generation? So can you emphasize more on that? So you mean, for example, the destination I'm going to define, like for example, processing plants or what exactly? DUP generation, okay, ultimate bit. So I think, so the software will respect, for example, so if, for example, if you have defined some, if you have defined plants basically or processing destinations, the software will not, it will respect those rules that you're going to put out. It will respect the processing cost for that. It will respect the different parameters you're going to put out, but it's not going to overwrite. It will only suggest when it comes to stockpiling and when it comes to mining. Sorry, when it comes to processing. But if you can maybe emphasize more on your question, that would be very helpful.
There is a question, Mehdi, from
Mhm.
Danielle.
Okay, so how does Maroma schedule handle variable supply rates to stockpiles, especially when multiple sources feed into one stockpile with fluctuation production. So the software allow you to define, like I said, multiple supply rates. So for example, if you're talking about internal sources like stockpiles that are getting ore from the pit, you can define various, or you can define a variable reclaim rate. Okay. Now, when you're talking about supply rates, so supply rates basically we're talking about external sources like underground or like things that we are purchasing. So the software will try to, when optimizing, it will try to respect those to 800%. So if you're talking about supply, it will never exceed that supply. And if you're talking about reclaiming, it will never surpass that reclaiming rate that you're going to put out. So the software, like I said, it will try to respect all of your constraints, all of your rates 100% simultaneously with an optimality gap.
There is a question, Mehdi,
Yeah.
on the
So
chat
how
box.
can I discuss the terms of the test use of the program with? Um, the terms of the test. So do you mean, do you want to test the software? So you can discuss it. You can, yes. So you can send us an email, and then we can reach out to your to the business lead of your region from Datamine, and then discussing with our business lead, we can discuss the opportunity of giving you trial licenses. So you can reach out to us via email after this session. Currently, no. So is there a functionality that compare scheduling scenarios? So currently, no. But like I said, in future releases, the software will allow you to generate automatic reports for each schedule that you can that will allow you to easily compare between multiple scenarios. For example, for each scenario, when a pushback is coming, starting, ending, different rates, different how much ore you're getting, how much waste you are getting. So currently, there is no automatic way. You'll have to do that comparison manually. But in future releases, with the automatic reports and charts, it will allow you to compare between different scenarios.
Now, there is another question, Mehdi.
Yeah. So do you think that if I'm a user of Studio NPVS, I need to complete training to switch to Studio NPVS Plus? Not really. So if you are already a user of Studio of NPVS, that means you know already 90% of Studio NPVS Plus. So only change is the Maroma Scheduler. The Maroma Scheduler is built on the previous, like it has a similar workflow, or basically it uses the same parameters and inputs of the previous Studio NPVS scheduler. So I think a 1 day or 2 days training should be enough to get you going with the Maroma scheduler. And as I mentioned, it's, and even as I presented, it's pretty straightforward, very user friendly, and more simplified than the previous scheduling in Studio PVS. So it shouldn't take you a lot of time to switch into Studio PVS Plus.
All right. So I think if there is no more questions, uh, we can wrap up this the session for today. Thank you so much for your attention, and let's we will wait for you also on the next webinar. Thank you so much, and have a good day.